Okay, so this question says that a game is relatively close if the score never differs by more than 2. And if there's 12 goals in the game, how many ways are there for the game to run? First thing to know is that this thing is kind of complicated, this condition is complicated. So let's try to find an alternative condition such that this implies this. So condition implies condition X, and condition X implies condition. So basically, finding an equivalent statement that is way easier to compute. If the score never differs by more than 2, so let's see what would happen at the first few moves. Suppose that at the first time the A gets the goal, then for example he gets the goal again. So now you're forced that B has to get the goal, right? So that's just an example. The tricky part here is that you have to observe when is this condition very important. When will it really restrict your movement? The first thing I noticed that if there's an odd number of goals scored, when there's an odd number of goals scored, it's impossible for them to be equal. Hence, the difference must be exactly 1. It cannot be 3 or 3, 5, 7. It cannot be 2 because, or else the sum would become even, because the parity of difference is always the same as the parity of the sum. Hence, after an odd number of goals, like after the first goal, third goal, up to the 11th goal, the difference is exactly 1. So maybe you could have an idea that maybe that the condition of exactly 1 goal, 1 difference, after an odd number of goals, implies, if and only if statement 2, score never differs by more than 2. Okay, let's try to see. If there's exactly 1 difference after an odd number of goals, then before that, the score difference could have not been more than 2, since it changed it as most 1. And afterwards, the difference could not also be more than 2, because since a change in difference at most 1. So this one implies this. Score never differs by at least 2 implies this one is shown here, because after an odd number of goals, the difference is the odd. And it can't be 3, 5, 7 or greater. Hence, let's just try to count the number of ways we could do this. How many ways are there for it to be exactly 1 difference after an odd number of goals? So we're just hoping now that this one's easier to compute than the original one. Let's just put this one in the spotlight first. So actually we could notice that there's symmetry. At the first goal, it doesn't matter who scored it. So for the first goal, there's 2 ways. Now let's see the 12th goal. By your assumption, after the 11th goal, the difference is odd, which is 1, which is odd. So it doesn't matter who scored the 12th goal already. So there's 2 ways here. Hence, our problem is reduced to the number of ways for you to go from the first to the third to up to the 11th goal, while still maintaining that the difference is exactly 1. So, okay, let's see how many ways are there to go from the first goal to the third goal. There's 2 ways. Either the advantage is maintained, or the advantage is shifted. If the advantage is shifted, suppose that at the start A is leading. If A is leading, then it becomes B is leading. The only way for this one is for B to score 2 goals, so there's 1 way. If it's maintained, then there has to be no difference in the number of goals. So it has to be plus what AB or BA. So here is two ways. Hence the number of ways to go from the first to the third, where the conditions exactly the same, is 3 ways. Okay, now let's go. For the first goal, there's 2 ways. The last goal, there's 2 ways. First to third, there's 3 ways. Third to fifth, there's 3. Fifth to seventh, there's 3. Seventh to ninth, there's 3. Ninth to 11, there's 3. When you multiply all of these, you get 972, which is our answer. And that's because all of these are independent from each other, so they don't influence each other. As after the third goal, the condition is exactly the same as it was the first goal.